it like this.
Figure eight.
But then you have to write make two.
Yeah, it's easy.
I literally go like this. That's my 8. Sometimes it looks open, sometimes it doesn't.
Wait, you don't do figure eight?
That's
worse.
That's worse.
You don't do figure eights?
Why not
Where you go like
figure
that?
8?
No.
That's the
Why?
easiest way, where you just go figure eight.
Nah.
See? You
Yeah,
can write that
it's
so much
so
quicker.
much easier.
No. Don't
No,
like
she
it.
didn't. That came out of your. That part came out of your imagination. She wrote that just as fast.
Yeah,
How she
but
did the other
one
one.
she did quicker than the other one she did slower.
Because I had to think about it, because I'm not used to doing that. So this is faster for me. Listen, I'm 42 years old. It's not going to change. It's not going to change. This is where I am in my life. Deal with it. Griffin.
Why not just figure 8?
Okay, we're going to classify values today. Hopefully you guys got a lot of this last year in 8th grade pre-algebra, but if you didn't, it will be pretty obvious for you now. Do you guys know what Russian nesting dolls are?
Yeah.
Yeah? Where you have like a tiny little doll and then it fits inside, right?
Yeah.
So classifying numbers is kind of like that.
It is.
Just
You
different.
have like a tiny little set of numbers that only fits there, and then the next set includes new numbers and those, and the next set, right? So we're gonna try something I've never done before. It may work out, it may not. We're gonna draw like the nesting dolls. So kind of looks like this, right? Like a pair, kind of. You guys know what I'm talking about? Like, this is real bad, but we'll just pretend. You only need one of them to be good, like the inside one to be decent.
You can just trace it.
Should I take up the whole page?
No, just like 2/3, because we're gonna keep growing it. Like so, just right here. Here, I'll see. Right. So these would be our natural numbers. If this works, I'm like gonna be so excited. I think it will. So natural numbers are the numbers you can count, right? 1, 2, 3, 4 on your fingers. You can't count the number 0, right? It's not a thing if you're actually counting fingers, right? Like there's no 0 finger, right?
Well, you can
No, that doesn't count.
Well, this does.
No, 0 is 0,
Well,
right?
because then you go 1.
This is what I do. You like that?
No. If I'm going to be pointing to a finger, there's nothing I would point to that would be 0,
0.
right? Okay. So we've got the natural numbers, and then natural numbers with 0. So we've got another nesting doll. These are going to be our whole numbers. Oops, that's not going to fit. Let's try it again. So these now have 0, 1, 2, 3, and so on. And I always tell students, like, the way to tell the difference between natural and whole numbers is whole numbers actually has like a 0 in it, right? That O looks like a 0. So that's how you get your whole numbers. How are we doing? So natural numbers are whole numbers, but whole numbers are not all natural numbers, right? So the little doll fits into the next size, but the next size can't fit into the smaller one.
If you really try it, probably.
I mean, you have to break it,
We
right?
just have drawn a circle. That would have been so much easier.
I like
Yeah.
the nesting doll analogy. That's what we're going to go with. Okay.
I'm drawing a circle. I'm sorry. Mine looks so weird. I have to draw a circle.
I'm not starting on the page because I can't draw whatever this is.
You should have said John.
It's a Russian nesting doll.
So when you get integers, now you have your negative numbers, right? So again, natural numbers are whole numbers. Whole numbers can be integers. because we still have that 1 and 2, right? Integers are all positive and negative whole numbers. And then our last one, those of you that have made it this far, didn't give up.
I have not.
Now we have rational numbers.
Oh, it's bad.
That's everything that's weird. Put everything weird in that category.
Right? Rational numbers are just like fractions, but fractions can be written in 3 different ways. How can fractions be written? Decimals, percents, right? So as long as it can be written as a fraction, it's a rational number. So how could I write 2 as a fraction?
2 over 1.
Exactly. So whole numbers are also fractions, okay? So we might have something like 3/5. We might have something like 12.25, right? How would I write 12.25 as a fraction? 12 and
1/4.
12 and 1/4, okay? Maybe I've got 0.6 repeating. How do I write that as a, it could be 2/3 or 6/9, right? Those are the same equivalent fractions, okay? So all most fractions that end up being a repeating decimal have 9 in the denominator. Okay, we'll spend some time on that. You okay, sir?
Yes.
You sure?
Yeah.
I wouldn't go that far.
So those are our rational numbers. So rational numbers include all of the integers, include all of the whole numbers, and then we have natural numbers. So the Russian doll, I'm really liking how this actually worked out. I'm gonna come around and check yours out.
Mine looks really
That's
good.
good. That's good.
I don't know, you can call it mine looks really good.
Don't you feel that circle? I can do it if I want. Better want to.
I feel a circle.
Thank you for the request. Coming around, looking at you.
You're welcome.
You have good.
Nervous whenever I talk to the girls.
If you had a pencil, wouldn't you think it goes the opposite way from where
You're hitting it, and you're hitting at the very end, which is making it easy towards you. Easy hitting it like this.
File for a different reason.
Come on. On the side, yes.
It has little
Listen,
grooves,
I'm actually, you
Yeah,
didn't give up.
and you
You
hit
didn't
yours.
give up.
Oh, well, mine actually doesn't have any.
Yours has, they all do. So if you hit, well, if you hit that pencil grooves, it'll still go that way. But if you
No,
hit
but
it,
look, if I hit it like, if I hit it like this,
yeah, but you're not hitting it, you're pushing down.
and yet it's still doing this. But then when I hit it,
Okay,
Mine's because it's hitting one
So,
thing.
then I'm hitting the exact same
that-
place. I'm hitting that.
inevitably happens in all the classes I teach. It's not just algebra, it's not just pre-algebra, it's everybody. But some students decide, like, I'm just gonna write down what I want. And that's not a good strategy, okay? If I, as your teacher, put something up here for you to copy down, that means it's important. Like, I promise you, I mean, look around my room. Do I, like, give any of you the impression that I like clutter?
No.
Or that I'm going to
Yes.
have things that are unnecessary?
Yes.
Right? That's really
Yeah.
It's
No,
Griffin,
no,
don't
no.
listen to him.
What do I have in here that doesn't serve a
I
purpose?
think it's
A lot of stuff.
That right there. That.
Lines.
That doesn't serve a
That's just
purpose.
me trying to be creative, but I don't have.
It doesn't serve a
anything
purpose
in here.
though.
Yes, it does.
What purpose does it serve?
You're trying to simplify a fraction.
What purpose do these awards have?
I mean, to me, they're just.
What purpose do these awards have?
There's
I think
one
that's
club
fine. That's for me to feel good about
Do
myself.
they not give those out anymore?
I don't know.
Hey,
It's
what
kind of
about that
wild.
picture of Mr.
That's there to motivate you.
Don't you
He's
know?
scary.
Okay, so back to my point. I will not have you write down things just as like a time filler. I'm not going to give you information or have you write anything down that is not necessary. So you need to make sure you're writing everything down that I put up there, because here's what's going to happen. And I know this because I've been, like I said, I've been doing this a couple minutes. A student's going to come up to me and say, Mrs. Marsh, I don't know how to do this. My first thing is going to be, bring me your binder. Let's look at what you're looking at so I can see where the disconnect is. So what do you think usually happens to the student that doesn't understand what they're supposed to be doing? How do you think their binder usually looks? It usually has like chicken scratch, great drawings, super cool cartoons, doodles, you know, the occasional I hate math, that's fine. But that's why they don't know what to do, because number one, they didn't do it when they were supposed to the first time. They don't have any interest in going back and watching the video to do it again, because they skipped it the first time. And then they want me to help them. I'm gonna help people that want to be helped. How do I know that you're a student that wants to be helped? What's the first thing I'm gonna see in your binder if you really want to learn and want to be helped? Griffin.
Notes.
The detailed notes, right? I sometimes have to pick and choose which students I'm gonna spend time helping. And who do you think is gonna have the advantage?
The note takers.
The person that wants to learn. I'm gonna know you want to learn because you have put the effort in the first time I taught it, right? Because I have you guys for 45 minutes. I can't get around to everybody. So if somebody really needs help, I'm going to probably go this direction towards the person that wants the help, not the person that just wants me to do it for them. I'm not gonna do that. I will guide you. I will ask you questions to point you in the right direction, but I'm not going to reteach you a lesson that I already taught once. Does everybody understand?
Yeah.
Also, I do binder checks. Binder checks are the easiest A you could ever get in my class.
No.
Maybe,
Yeah.
No.
We get to use our binders.
right?
Well, no. Binders checks.
A binder check is when,
Binder.
well, this is when I type some questions into Canvas, such as, on Monday, August 8th,
Oh.
what were the examples I gave for rational numbers?
Oh, wow.
If you have that, you're set. You're good to go, because you have the answer, right? If you didn't write everything I wrote down, sorry, right? And don't come up to me and be like, I think I lost that page. I don't know what happened to it. No.
That might be legit for me.
Listen, I know what happened to it. You didn't do it, right? So
Yeah, that'd be pretty hard to lose papers if they all stand
I
here.
lose a lot.
you'd be surprised. So all of these things are my way of kind of forcing you, guiding you, encouraging you into being organized,
Out of my teacher.
right?
Oh yeah. Access.
Where are you going? You got plans?
No, that's the.
Oh, I know, but I mean, like, why is that going on?
Well, no. I said it like every day, but then like I said it yesterday, but it went again.
Oh, so you said it accidentally for daily instead of a monthly. Okay, go ahead. What were you doing yesterday at almost 3 o'clock?
Oh, I had to go somewhere.
Okay. Hop on your bike, take off.
Don't worry
Sure,
about it.
Mrs. Marsh.
Such a skillful one.
It's okay if it was just your alarm to wake you up after a nap. I have to set alarms for that.
Otherwise,
Otherwise, I would sleep
I
the whole day.
What?
What?
I had to go somewhere.
So you're gonna go on this?
So did you cancel it for tomorrow?
Right?
Yeah.
Yeah.
Apple alarm gives me
Did she ever stay with you guys or no? Is that-
Think you're
always entered. Always. Is that still a thing? All right, so we have our nesting dolls of information here. Everybody did a great job of getting the information. Even if it's not a nesting doll, you still have it. All right, so we have this. This is great. All of these numbers have something in common. And then we have this little random, we'll just make it a square over here. Yeah, make this a square so you know it certainly would not go into the nesting doll. And in this little square are these numbers that nobody likes called irrational. Right? Those numbers are no bueno. They're difficult to use. They are hard to add, subtract, multiply, and divide. But they are values that count for something, even if we don't like them. What is the most popular irrational value? Story? Pi, right? Pi just kind of hangs out by itself, goes on and on forever, right? It's ugly. I mean, it's fine when you're doing volume of things, but it's not an easy number to actually manipulate. Okay.
It's fun to use though.
Sure. Sure. Right? I always consider these like the crazy numbers. Right? They're unpredictable. Okay. They're a little crazy.
No, my pencil went broke.
I think the little yellow one is still back there. Yeah. Okay, so let's do some practice. I'm going to give you a value and you're going to tell me which category it fits into. It might fit in more than one, right? So we're looking for one or more categories that these values can fit into. So our first example is -5/2. What would that be considered, Griffin?
It can fit in everything but the irrational numbers.
Not quite. So I think you're looking at it in the opposite direction. So the ones that are on the outside layer can only be that one. Does that make sense? So if I look up here at rational numbers, these are only considered rational, but integers can be rational. Rational can't be integers, right? Whole numbers can be rational. Rational cannot be whole might not be whole numbers, right? So like a fraction is not considered a whole number. But a whole number can be written as a fraction, which makes it both of those. So this is actually only rational. No, because, no, so these can go this way. This can't go back up into the smaller part of the doll. This is Mrs. Marsh. Hi. Sure thing. Bye-bye. Bye, Wilhelm.
I'm going now?
That's the news.
Oh.
What time did you think you were supposed to go?
3:30.
Yeah, because your pass says later, right?
Yeah.
Maybe
And my dad said later, but I guess.
maybe Dad has other things to do. Okay, have a good one. Okay. Here we go. Second example. We'll get better at this. -823. I'll give you a hint. 2 categories. Griffin?
Integers and rational.
Integers and rational. How about just the value of 0? Mason?
Whole numbers, integers, rational.
Yep.
Irrational.
Nope, they're rational. Yep, they're not irrational. Because it's not a non-terminating, it's like kind of one of those weird special situations because it's a whole number. So we've got whole, integer, rational. Square root of 81. What do you think, Nate?
Whole and integer and rational.
Yeah. Why?
Because square root of 81 is 9.
Exactly. Couldn't it also be
Natural.
natural? So we've got natural, whole, integer, rational. 3.467 ... That should be a clue for you. Carson.
Irrational.
Irrational. How did you know that?
Because decimal without repeating for like multiple different numbers makes it irrational.
Yeah, this ... is your I don't terminate ever, which means I'm crazy, which means I'm irrational. Okay. .2 repeating. What do you think? Caleb?
Rational.
It is rational. Anybody have questions about how to classify these values? Again, this should be review because I spend a lot of time on this when I'm teaching pre-algebra, so hopefully some of it like is still in there floating around from last year.
Possibly.
Maybe. Okay, so if you have a binder, go ahead.